There's going to be some consistent items that you're going to see throughout my notes to make sure that you understand the difference between, well, frankly, arrays and matrices, but also to understand if we're interacting with a row or a column. I'm going to be labeling things out X and Y in this example, but from here on out, I'm going to literally use the variable row and the variable column to kind of lay things out on exactly what I'm looking for. So we'll show you that here in a moment. But anyway, here's a longer, or bigger, I should say, matrix that you and I are going to be using for some of the exercises. Yeah, we're going right to exercise here in a minute. There really isn't anything surprising about that, but we need to understand the importance of the pattern in the coordinate system when we're using a matrix. Really, one of the biggest programs, the introductory program that we use for matrices, could be something like Minesweeper, where we have a particular item in the middle and we have to count all of the different items that are around it to see if there is a mine or not. So here's what I want first. There's going to be two problems I'm going to break in between. Is that I want you to tell me what are the coordinates around 2, 4. Now, they're connected, they're touching 2, 4, so I'm not asking for the whole thing here. I'm just asking for the ones that are right around 2, 4, and then we'll get into the second one here in a second. So do that first one first. I'll go over and answer, and I'll be right back. I'm only worried about those values that are, or elements that are directly connected around 2, 4, and I'm worried about them because there might be algorithms that are looking for something around a certain point, like we talked about in Minesweeper. Notice I'm always talking about it's going to be row and then column, no matter what. If I'm at this location, the order that we address or identify the location is always going to be row and then column. So if that is 2, 4, I'm going to make this easy on myself. I'm going to do the same row first. So if I know this is the same row, so that's definitely going to be 2, but I went back a column, because remember, let's pretend this is 2, 4 here right at C. The next one back here is going to be row 2, column 3. So the one over there is going to be 2, 3. Now, let's follow the pattern. 2, 3, then 2, 4, and then 2, 5. Okay? Now, I'm going to go up 1. Up 1 means that I'm going to lose a row. I'm going from row 2 now to row 1. So all of these are duplicated except for the row is subtracted by 1. So it's going to be 1, 3, 1, 4, and 1, 5. Whew. So the last row, yeah, it's going to be 3, 3, 3, 4, 3, 5. That's simple. Now, I want you to notice for now problem number 2 here, there's a pattern to this, but there's a mathematical, very simple pattern. And notice I've kind of given you a heck of a lot of, hints here on how to do that. So I want you to figure out what is going to be the mathematical, equation of how we would move from our center to get to this point. From this point of 2, 4 to 3, 4, the only thing we added was, well, an extra x. What am I going to do for the other ones? So again, I'm giving you a heck of a lot of hints here, so I think you should be pretty good, but let me know. So we'll be back in a second, get this one done. So I'm going to make this easy, frankly, on myself. I'm going to use what I had up here and kind of knock out a few things right off the bat. So I have 2, 4. That one was, the one on the upper left-hand corner was 1, 3. So subtracted from both x and y by 1, so that's going to be my x minus 1, y minus 1. I'm lazy, just like you guys. This bottom one's going to be the opposite. We're going to add 1 to the x, and we're going to add 1 to the y. Because again, here from 2, 4, this one was going to be 3, 5. We already went over that. This one, the only thing that changed was the row didn't change, because again, straight across here, straight all the way across. The only thing that changed was column, and the column went up by 1. So x stayed the same, y plus 1. But notice the pattern here in this line. We have x minus 1, xy, and then x and y plus 1. Notice there's a pattern. So get used to that pattern. You're going to need that in a lot of intro classes where they do some mazes, minesweeper. All these things are going to come into play here. And the last one here, the row changed. It went down by 1, excuse me, because that's row 2 and then went up, or here, I should put it that way. But anyway, so that's going to be x minus 1 and y plus 1. And again, it's just literally the opposite of what we had here. Okay? So notice the pattern that we're going to need that. Now, here's something else to keep in the back of your mind. When we're doing Minesweeper, remember, there's edges to the graph itself or the matrix itself. We have to be careful that we actually don't go too far either way on all the edges. So there's going to be some if statements if we have some type of setup like this that we really have to keep an eye on. And that's going to be your challenge when you're given that particular type of assignment. So just a heads up that as we do this, it looks great so far, but what if we have edges to our application? We'll have to think about it.